Welcome back everyone to mini lesson number 5. This is going to go along with section 4.2, and what I want to talk about here is increasing, decreasing, and extrema, which is all first derivative test, but I want to do it with chain rule and product rule. In other words, I want to do a very difficult problem here with increasing, decreasing, extrema. These are the type of problems you're going to see on a quiz or test one day, so here's a great example for you. Okay, some things to keep in mind. Most of the derivatives will factor as a fraction. Okay, just like the chain rule factoring that you guys did for Miss Bear last year and the chain rule factoring we did earlier this year, a lot of these are going to work out to be fractions. Critical points, those are max mins, they occur when the derivative is 0 or is undefined. A fraction is 0 when the top is 0, and a fraction is undefined when the bottom is 0. Therefore, critical points will occur when the top or bottom of this function, this fraction, is 0. Now, not every critical point is going to be a max or min, but if there is a max or min, it's going to be at a critical point. I've only have one example for you, but it's long, so let's try this. We're going to find all increasing, decreasing, and our extrema, the max and the mins. I'm going to let you use a calculator to plug in numbers to check. I've already done it ahead of time, so I'll tell you what number I used, and you can check it on your own. So I need to do the derivative equal to 0. That's how I find a max or min. Okay? This is a product rule, and it's a chain rule. So this is going to take a little bit of time. First, derivative second. Plus second, derivative first. Okay? If you're having trouble with that, you're not going to understand the rest of this. But that's a product rule with chain rule derivative. Now we need to factor that, the stuff that you did with Miss Bear last year and with me earlier this year. So I want to find the smallest of each like term. So 2x minus 1 is a third. 3x plus 1 is a negative 1/2. That leaves a 1/2. I'm sorry. That leaves a 2x minus 1, a 1/2, and a 3, and a 3x plus 1, and a 4, and a 2. Okay? Chain rule factoring. Well, if I distribute in and start combining some like things, I'm going to get, this is going to stay the same. Now inside here, I'm going to get 3x minus 3/2 plus 24x plus 8. Let's combine some more like terms. Again, the beginning is going to stay the same. Inside here, I'm going to get a 27x, and if you put 8 minus 3/2, you get 13/2. Now I can't leave that last factor like it is, it's got a fraction in it. So I'm going to pull the 1/2 out of it, so I'm going to have a 1/2, 2x minus 1 to the third, 3x plus 1 to the negative 1/2. If you pull a 1/2 out, you're going to get a 54x plus 13. So that is factored. Let's make it a little bit prettier. Let's simplify it, clean it up, turn it into a fraction, however you want to think about it. So I've got a 2x minus 1 to the third on top. I've got a 54x plus 13 on top. I have a 1/2, and I have a square root of 3x plus 1 on the bottom. That's a lot of work, but that's only the factoring part of it, the algebra part. Now let's do the calculus part. This is the derivative. How do I find a max or a min? I take the derivative and I set it equal to 0. So let's find the critical points. Critical points are anything that make it 0 or undefined. What makes a fraction 0? When the top is 0. What will make this 0? X equals 1/2. What will make this 0? It's ugly, but it's x equals negative 13 over 54. Okay. Those are the only zeros of this problem. Critical points are where the function is undefined. Where is the derivative undefined? When is a fraction undefined? It's undefined when the bottom is 0. What will make the bottom 0? Negative 1/3. So those are my critical points. Those are the points that I want to check. So I draw a number line. The only numbers I care about are negative 1/3, negative 13 over 54, and 1/2. Now I'm going to see what happens to the slope of each of these. So I'm going to pick a number in each of these 4 intervals. I'm going to plug it into the function, into the derivative. If the derivative is positive, then it's increasing. If the derivative is negative, then it's decreasing. Let's start over on this side. I'm going to pick the number 1. If I pick the number 1 and I plug it in here, I'm going to get a positive derivative. So I know it's increasing there. Let's pick a number in here. I picked 0. If you plug 0 into this entire thing, you get a negative answer. Again, I've already done this ahead of time. You would need to use a calculator to check this, plugging this in. But I trust that you guys can do that. Picking a number in here, I chose negative 0.3, because that's negative 0.3 repeating, and that's negative 0.2 something. I forget. If you plug in negative 0.3, you get a positive answer. Over here, this is an interesting one. I picked negative 1. But if you plug in negative 1, you get an undefined answer. Why is that? Well, if you plug negative 1 in here, you get negative 2. You have square root of negative 2. That causes a problem. You can't take the square root of a negative number. If you look all the way back at the original problem, right here, we know that 3x plus 1 has to be greater than or equal to 0. In other words, the domain of this thing is only from negative 1/3 to infinity. We just saw that. That's why there's no increasing or decreasing over there. So, let's classify our increasing, decreasing. Where are my intervals of increasing? Well, right here, from negative 1/3 to negative 13/54, and also from 1/2 on out to infinity. Where is it decreasing at? Well, it's decreasing in this interval. Negative 13 over 54 to positive 1/2. I don't put this down as anything because it's not increasing or decreasing. It doesn't exist in the graph. So let's figure out now maxes and mins. This point is neither. It's where the graph starts, so I can't really count that. This point, the graph is going up and then down. So what kind of point is that? It goes up and then down, up and then down. This point is a max. How about this point? The graph is going down and then up. That means that's a min. If you wanted to classify this point as something, I would classify it as this. I would classify it as a min, only because from that point it's going up. But usually you don't have a problem like that. I made a difficult problem here. Okay? Quick review. Factor. Well, first of all, take the derivative, product, chain rule. It's a long process, but by this time you should have it. Start factoring. Factor all the way down as far as you can. Simplify this as much as you can. Set it equal to 0. Find your critical points. Draw a number line. Split your number line up based on your critical points. Pick numbers in each interval, plug them into the derivative. I don't care about the answer, I just care about the sign. Positive derivative means increasing. Negative derivative means increasing. Increasing to decreasing means that point's a max. Decreasing to increasing means that point's a min. Okay. Have any questions, come talk to me. You guys know where I am.